we are back for the next talk called Destructuring Frontend Monoliths with Microfrontends by Trishul Goel. Trishul is a professional frontend developer who writes React code for a living and volunteers for Mozilla just to justify his existence. That sounds a little bit dramatic. He also loves modern JavaScript and tries to use it to solve all of his problems, even the domestic ones. I will be asking about that one. This sounds very interesting. And he's expert in developing PWAs and browser extensions. So everyone, please welcome Trishul. Hey Trishul, welcome. How is it going? Maybe you are muted?
Yeah, thank you for your welcome.
Now I can hear you. Perfect. So welcome again, Trishul. How is it going?
All good, all good. Just fighting with the weather in Munich.
All right. So how does this work like with solving like the all life problems with the JavaScript? Are we there yet? Is
Uh,
this possible? Would be cool.
you have to get a bit dramatic on that one. Like when your wife asks you, like, "Hey, can you do this for me?" and I say, "No, I'm solving some JavaScript bugs." So
Okay, that actually makes sense. Like, yeah, I'm busy. I'm really busy. I have to solve this and then maybe. A-
yeah,
Anyway,
that
so
works all the time.
I see. So destructuring front-end monoliths with micro frontends. I'm really curious about your take on this topic. So can we get started?
Sure.
Hello everyone, I'm Trishul. I'm principal engineer at Westwing. By the day, I architect some e-commerce solution for Westwing, and by the night, I volunteer for Mozilla. And today, I'll be talking about restructuring front-end monolith with micro-frontends. So, what is a monolith? Monolithic application is designed to be self-contained. Components of the program are interconnected and interdependent. A monolithic app is all-in-one app. Everything from database to UI components are in single place. In modern days, we already broke this into backend and the front end. The backend is furthermore divided into microservices. But in modern times, with evolvement of JavaScript, we have way more code in the front end. All the business logic, most of the business logic resides in the front end, and hence the quantity of the code is increasing day by day in the front end. So what we have now is something called as front end monolith. And with the front end monolith, we have the problems of monolith in the front end. All the code in the monolith are in a single place. Increasing size of repo every day. With each feature, we add more code. With more code comes the more complexity. Increase inter-team dependency. Since everyone is working on the same code base, all the teams are interconnected and interdependent. One change will be causing effects to every team. Slow development to deploy cycle. So since all teams are interconnected, we have to take care of every team together. And for a single deployment, every team has to sync and make sure that what the changes are going to live are pretty stable and nothing is breaking on the live. All in all, we are only as strong as the weakest link. If one of the team broke anything, everyone has to stop and fix that thing until the next deployment. So what's our solution? Enters microfrontends. What is a microfrontend? Microfrontend architecture is a design pattern where monolithic frontend app is restructured into small independent apps. These micro apps are stitched together as a single page on the fly. It's like breaking a huge piece of code into small bits and pieces. So, each microfrontend is a standalone system. That means it's able to run individually and independently on its own. Each microfrontend has individual repository, so there is no direct code dependency between each system. Each system is built individually and can be ran individually. Since the repositories are independent, we have independent CI pipelines. You can write different test suites for different systems without interfering any other system. And finally, which I think the best quality of microfrontend is individual deployment. Since it has individual repository, individual CI pipelines, it can be deployed independently. It is independent from any other system. So let's say if one of the system is, let's say, having some problems, the other system can move ahead and deploy. obviously with testing, but it's not a blocker. That enables parallel development cycle. Since every micro frontend has their own space, so every team moves with their own velocity, and hence they move faster. Let's have a look at architecture of micro frontend, how this is architected. Consider this. There's a host app, and let's say there are 3 remotes. Each remote exposes some modules in the wild. Let's say some components, some functions, and host consumes them. The host does not need to care about how these remote modules were built, how they were published. All it needs a remote URL, which it can use to consume these modules, just like consuming any S3 package. Let's have a look how we did in Westwing. So this is, let's say, example of very common e-commerce page. It has header, footer, some pages like home page, product listing page, product detail page, payment page, checkout page, cart page, etc. and so on. So in a monolithic world, all this code will be in a single place. All the teams, let's say product listing page team, cart team, payment team, will be working on the very same code. So anything which has to be deployed has to make sure that all the code is working as the way we want. If anyone breaks anything, the whole team has to stop. The extended team even has to stop until the error has been fixed. But in micro frontend, what? Each page is a micro frontend. So homepage has its own micro frontend, PLP has its own micro frontend, cart team has its own micro frontend. So this enables to destructure the teams in not just the code, but the team itself into different parts. So cart team can move with their own pace. Product listing page can move with their own pace. And each micro frontend exposes their modules, and these modules are consumed by something we call as Appshell, the host, which hosts the header and the footer. So whenever a page request is made, the page request is made to the Appshell. The Appshell has header and the footer. Based on the route, it consumes the micro frontend and builds the page on the fly. So for example, when a user hits for a listing page, so Appshell consumes the product listing page package and mix it with header and the footer and serve a complete page to the user. While designing the system, we decided that Appshell should host, apart from header and footer, all the shared business logic. Logic like login logic. So we wanted Appshell to have all the login logic. The login state of the user. If the user is not logged in, it should initiate the login pop-up and let the user log in. So that we don't have to do this in all the micro frontends. All the micro frontends just need to count on Appshell that if the user is logged in or not. If not logged in, they just send signals like, okay, make the user log in and give us the data back. Apart from login, we put all the tracking logic in Appshell so that we have a single place where all the tracking is maintained. May it be Google tracking, Facebook tracking, whatever we wanted, we put it in Appshell. So this enables us to centralize the tracking, and we just expose the functions from the Appshell to the micro frontend. So all micro frontend needs to do is just hack on that function and send the signals. And they do not need to care how these signals have been treated. The Appshell needs to forward the signals to the respective third-party websites. Apart from tracking, we put some system config there. So we have lots of system config based on environment, based on countries. So instead of doing this in all micro frontends, we did that in Appshell instead. So we have a single place where we can see what all config is served throughout the system. Whenever a micro frontend needs a config, they just request the Appshell and get all the configs which they need. And finally, we put the routing. So we do not allow micro frontends to handle the routing. We had all the routing in the Appshell. So all the routes in the Appshell, and Appshell builds a page with the respective micro frontend based on the route. So this enables us to make sure that routing is in a single place. So if we want to change the route in future, it's just one place we need to kind of handle it, not everywhere. So now we have been saying that we have to communicate a lot between micro frontends and the Appshell. Like for example, exposing tracking function, exposing notification function, and the login data has to be passed to the micro frontends. So there's a huge requirement of proper communication between micro frontend and the Appshell. So we figured out that there are broadly 2 ways to do this. First, if you use the same tech stack, let's say Angular and Angular. So it becomes very, very easy. All we have to do is pass the data as a param, as an argument of the function. So if you are using a route-based microfrontend, you can pass as the route param. If you are using the modules, then you can pass the data as the arguments of the module. What if you don't have the same tech stack? You have different tech stack. Let's say microfrontend is in Angular and the Appshell is in React. Then how would you do that? So for this, we exploited the native JavaScript functionality, the custom DOM events. So custom DOM events are technology agnostic. They are vanilla JavaScript and available in the browser. So all we need to do is the microfrontend or the Appshell needs to subscribe to the event, the custom event, and another service, let's say another microfrontend or the Appshell just emits the event and the subscriber gets the data. So let's have a look at simple DOM event, how it is generated. So let's have a look at this event. So this is my event. This is a custom event we created. And as we would do any listener, like click listener or anything, we just listen to this event with document.add event listener. And on whenever this event is received, we do some action. And let's look how we will emit this event. All we need to do is create a new constructor of custom event, new instance of custom event, and pass the data which we want to send. And finally, dispatch this event. So whenever we dispatch this event, whosoever is hanging on to this event, adding listener to this event, will get this event and do the action requested. For example, we here just log the data. So we would have got the custom data like this. So this enables us cross communication in a easy way, the native way, so that we do not need to do anything extra from architecture point of view. This comes out of the box from JavaScript, and it's supported by almost all the browser. So this is pretty neat way to communicate between microfrontends and the Appshell. So this is how we designed the whole microfrontend architecture at Westwing. Now let's have a look how we implemented that. So at first, we tried some traditional approaches. For example, iframes. For a very short span of time, we tried that, and very soon we realized this is leading us nowhere, and this is really, really a bad approach. For a short while, we tried with node modules. So we exposed some node modules of the components and used them into the Appshell. But with this, again, we got into the same problem of block deployment. If one team broke something, we have to stop and fix it, and then only we can go forward with the other teams, because deployment is necessary for updating the node modules. So we were still in the same problem. What did we do? With Webpack 5, we got module federation. Module federation allows Webpack to reference remote modules which are not available or known to the compiler at the compile time. These modules will be known only at the runtime. Let's have a look at this again. So remotes are compiled individually and independent from host. And the host just requires a reference while it compiles. So at the compile time, it really do not needs to know where the remotes are. Only it requires them at the runtime. So this helps us to decouple the deployment of host and remote. Now let's have a look how we did it in the code. At Westwing, we use React for development, but I tried to translate the same with Angular. Hopefully it makes sense. Let's have a look. So first of all, we need to have a shared component which we need to share across. So for example, there's a shared component. So it's a very basic Angular component. All it does is just import some HTML, template, some CSS, and that's it. There's no functionality here. So we need to expose this component. So this is a part of my module federation, basically the magic of module federation. All you need to do is define a namespace for this remote, let's say remote. And we have a file called as remote entry. So what remote entry is, it's a meta file basically holding all the data about the microfrontend. When host requires this microfrontend, it looks for this file, and this file directs the host for all the packages, let's say the chunks, whatever is required. And finally, the expose module. So this is the namespace of the module which will be exposed. You can expose multiple modules within this namespace. So this is the address on the file address where this component is actually present. And then finally, what module federation provides is some shared libraries. So for example, this Angular core, common, and router will be used in Microfrontend as well as the host. So instead of loading it twice or thrice, just say that my Microfrontend will use it from the host. So do not load the instance of Angular from the Microfrontend. Now let's look how the host config looks like. So again, we have this module federation plugin. So here we need to define the remote, the same namespace which we use to expose, and the address of remote entry file, a remote address of the remote entry file. So whenever this application will fire up, it will look for remote entry on this URL and set up all the modules. And again, we need to define what modules we will be allowing to share from Appshell. So once this connection is set up, like the microfrontend exposes the modules and the host consumes the module. So this is available in host. The microfrontend is available in the host to consume. And how we would consume is pretty straightforward. All you need to do is just do this. And this will be behaving the same way as you have imported any other modules. For example, this is the namespace of the remote, which we use in the config. And this is the exposed module name. So for us, it's remote/shared module, and we will get the shared component. And we can use it like any other Angular component throughout your Angular app. So for example, I created this example where we use the shared component as the route component and pass some data, and that's it. So it's that easy. With that, let's have a demo of this. Just a disclaimer, I'm a React developer and I'm trying my hands at Angular after very long. So if something goes sideways, please bear with me. So here I have a repository with two projects. One is host, one is remote. So let's have a look at remote config. So remote config is just a small webpack config which has module federation plugin. And in this we have the namespace of remote, we have remote entry file, and the module which we expose. So basically a shared module which is coming from this remote repository and the exposed remote module. Now let's have a look at this shared module exposed component. Let's go to src, shared, and this is very small basic Angular component. It has a template, it has some styles, and a small onInit function where it passes the route data to the template. Let's have a look at the template. In template, all we do is to just say that this data is coming from where. So let's have a quick run of this. It's a remote. Let's run the remote. Hopefully it works. Meanwhile, it builds. Oh, it's already built. Let's have a look then. Okay, this works. I can say I'm an Angular developer now. So, so this is a component, the shared component which we are looking for. So, and it says it's coming from the remote. Let's have a look at our code again. So this was our app component. In this app component, we just pass this route, and let's have this look at this routing. In the routing, I pass the shared component and the data from remote, which is basically being displayed here, the remote. Now let's have a look at the host app. So in the host app, give me a second. In the host app, the same thing, module federation, all it does is expects a remote and the remote address for the remote entry file and some shared things, and that's it. This is the only configuration we need to do in the host. And let's look how we consume this shared module. So let's go to app and look for our routing module. So here we just consume shared component as it is, like the namespace of the remote and the namespace of the exposed component. And this shared component, we can use it as if it was any other component at the project, let's say home component, and we can pass the data whatever we want, let's say host. Now let's have a look what if this runs correctly or not. Meanwhile, it builds. Let's have a look. Like it's a very small thing. Like we have just two anchor tags, one for home, one for remote, and it routes to home and remote. The home part serves the home component, the remote part serves the remote component. Nothing fancy. And let's have a look if this worked. Okay, our host project is ready, and let's see the functionality. The home, it's working, and remote, the same component is working, the shared component, as if it was working in the remote, and it says like it's coming from the host. So just to confirm it, we can do some changes. Let's go to our remote, expose component. Let's say and let's see if this works. First, let's check our remote app. Okay, it is here. And let's check our host app. And this is here again. So this explains how we can use a shared module from remote to host. Just one more thing I wanted to show you is this remote entry file. So this remote entry comes from 4300, localhost 4300, basically, which is a remote app. And this remote entry kind of furnish and runs all the required modules, which is required by the remote the shared component in the host. So this code totally comes from remote, not from the host. So I think that makes some realistic view on how this module federation works. Cool. Then let's go back to our presentation. So as we see, with Webpack 5, the seamless integration of Microfrontend is possible. The Microfrontend behaves as if it was the local component of any Appshell. And with this, the Microfrontend architecture at our organization really kind of got a boost. And this helps our team to move parallelly, and the velocity of teams increase like anything. This is how pretty much we build the whole Microfrontend architecture in Westwing, just using React. While building this, we faced some challenges. One of the biggest challenge was design consistency. We have to make sure still the code is split into different repositories. The end product will be the same throughout our website. The website still is same for the user. So all the components which are on UI should look same. So for this, we implemented UIKit. So UIKit houses all the UI components, and all the microfrontends use the UI components only from the UIKit. They do not implement of their own, but just use it from UIKit. Even if they want to implement something for their microfrontend, they put it in UIKit and then they use it from here. This ensures the design is consistent throughout our website and user sees it as the same part. The next one we faced was initializing a new microfrontend. With each microfrontend, we have lots of setup. For example, CI pipelines, the S3 upload script, the Kubernetes setup, the Docker setup, and whatnot. So to write this for every microfrontend, for every repository, it was really a pain. And we do not want to do this so that we do not want to repeat on this for every microfrontend we create. So what we came up with is templating engine. So we use a templating engine called as Tenpureto. So this enabled us to kind of photocopy our microfrontends. So this templating engine basically lets us to create a template and where we can put all our code structure, our CI pipeline script, our S3 publishing script, our Helm scripts, our Docker setup, everything. And whenever we need to create a new microfrontend, it just wraps up a new repository with all the changes which are there in template. So if you look into an example, so this is how our Tenpureto template works. So we have a template here, and we can have multiple templates, but for now we concentrate only on microfrontend one. So when we use this template, it wraps up a new microfrontend repository, and with this comes everything like our Docker file, CI setup, our Helm setup, our end-to-end test, our Docker compose setup, and the whole complete the for the basic folder structure for the apps, and obviously the all the webpack configs which we need. So this helps us a lot to move forward. And not only it creates the micro frontend for us, it also helps us to maintain it. So if we need to change anything, let's say we need to implement a new S3 pipeline, S3 script for micro frontends. So instead of doing it in every micro frontend, we can just update the template once, and all micro frontends in turn can update their own templates. So this kind of smoothens our experience to propagate the changes throughout micro frontend systems for different micro frontends. So the next one was decoupling code from Appshell. So Appshell, basically what we did, instead of creating a new Appshell, we named our whole monolithic app into Appshell. And one by one, we tried to decouple the code from Appshell. It was a long process, but still, I would say it's pretty worth it. So as the process of decoupling code from Appshell, the first thing we did is moved a lot of components to UIKit so that we can be reusing these components into micro frontends and ensure our design consistency. Then we got lots of logic which has to be shared between the micro frontends. For example, formatting logics. We want throughout our website, the price formatting should be same. The date formatting should be same. So it's very inevitable that if we do it multiple times, it may leak out somewhere. It may backfire us sometime. So instead, what we did, we created some utility node modules package where we published these functions, and then the micro frontends just use these functions in their code. So this ensured that all the logic, which is basically static, remains same throughout our website. And finally, one of the biggest challenge we faced was building an efficient developer experience. So to run the micro frontend system at our local systems, we have to run all of the micro frontends and the app shell, which is not ideal. So what we did is in Appshell, we expose the URLs of micro frontends as environment variables. So all we need to do is pass the remote entry URL, right? So we expose these expose custom environment variables and use those variables to pass these URLs. And we created a Docker image out of it. So with Docker image, you can run the whole micro frontend system with the staging URLs, and it is standalone working fine. But when you need to run on your local machine, all you need to do is run your local micro frontend into, let's say, 3000 localhost port, and then pass this URL as an environment variable into this Docker image. So all the other micro frontends and Appshell will be running from the staging URL, and the local micro frontend will be running from your local host URL. So this way, we improved our developer experience, and instead of running all the processes together, all we need to do is run one Docker image and one local node process. So this helps us to boost our productivity a bit and make sure our developers are not frustrated. We have solved many challenges on the way, and we are still solving till date. We are far from done, but still we can say that we have improved our developers' life. We have made our developers less frustrated and our PMs a bit more happy. The velocity of our teams have been increased just because of micro frontends. We are moving way faster than before. So with that, thank you everyone for attending my talk. See you all. Bye bye.
So thanks for the great talk, Trishul. Folks, please do not forget to ask questions in the Q&A or in the chat so we can relay it to the Trishul and ask him. And we already have the first question for your talk from Victor, which asks, what if a micro frontend needs subroutes? Where is that routing handled? So I think we can maybe add a bit context to that. So what if you have like a bit bigger micro frontend which needs to react to like the routing state of the application? How did you solve that in your project?
That's indeed a very nice question because we stumble upon this very same problem. So there are two ways to do this. Either hold everything in Appshell, let's say the host app, where you can micromanage every micro frontend, but that's not super ideal because in that way you have to control more stuff. But what we do is like pass the routing hook into the props. so that the micro frontend has even access to the routing of Appshell. So, for example, where we stumbled upon this is, for example, we have a product listing page, and when we apply filters in the product listing page, it changes the URL. So, ideally, with every filter change, there is a new URL, and it will be really chaotic if we port this URL to Appshell. The point of micro frontend will be kind of diminishing. So, instead, what we did is like pass a routing hook where we can just hang on to we can just pass the arguments from the micro frontends, and eventually it will change the URL as expected.
So if I understand correctly, basically the shell allows the various micro frontends to notify that the URL should change, but actually the shell is doing it for them, right?
Correct, correct. But the
And
parameters would be passed from the micro frontend.
right. And this probably is also related to what you showed previously, that you are using like these native custom DOM events, right, to communicate between the shell and the various micro frontends, which then brought me to a question where I wanted to ask if there is some kind of library to abstract on top of that, because like that you don't have to literally create like the instances of those custom DOM events, but if you have like some kind of abstraction on top of that where you can just call some methods which that service know about all the events which can be emitted or something like that.
I mean, for sure that can be done, but we don't want to do that because that basically ties up the Appshell to the micro frontend again. Because if you really kind of pass it down, then you are dependent on the Appshell or the host. We want to
Makes
have a kind
perfect
of
sense.
more freedom to the micro frontend, because the whole purpose of this is kind of break the deployment dependencies, so
Makes
that a
perfect
micro front.
sense.
Yeah, so that's why we don't do that. But what we do instead is with every release of Appshell, we release a types package, just types package, so that every micro frontend knows like what kind of basically the type of the event which Appshell expects, so that we do not need to actually communicate. Every micro frontend consumes that package. It's just type package, so anyway you need it only at build time. You don't need it at runtime.
That
So
sounds
that's
like
where
the
we.
best of the both worlds, right? So that you are
Correct.
like guaranteed that you are emitting events which the app shell actually can understand.
Correct. And still being decoupled into the different deployment process.
Yeah, that sounds great. So I hope this answered the Victor's question. Then we have Dennis, who is asking if it is possible to work with some state management, like for example, NGRX, or let's say if the React world, it would be the Redux with micro frontend. So for example, if a login is in micro frontend with his state manager, how it can share the state with the logged user info.
Okay, I get this. So first of all, you can use anything you want in micro frontend or in app shell. It doesn't matter, because at end of the day, just consider this micro frontend as a function which accepts some arguments. You can pass any argument in any form, may it be an object, may it be function, may it be just as boolean or string value. And when you pass it, your micro frontend can initialize your state. Like for example, on React, what if it's Redux? So for example, if app shell uses Redux, while passing, it will pass some object, and that object can initiate another Redux store into your micro frontend or ng store, whatever you want to use it. So it's basic. Just pass. The way is like I'm passing around the arguments, and how you treat your arguments, the data, it's totally onto you. It's totally flexible. You can use a store or native context or whatsoever you want to use. You have total freedom on it.
And that's probably like the best thing about this approach, that it really gives you freedom because you are decoupled. So I hope that
Correct.
Dennis is happy with the answer. Then we have Davide, who is asking if the every micro frontend has to rely on the separate repo, or if you can use the monorepo solution. I would like to add on top of that, because I also wanted to ask this when I saw your example where you had basically stuff next to each other in a single workspace. So then when you are kind of referencing the remote from the host or the host from the remote, right, that it's kind of easier. But what if those things are like in different repos? What happens then?
No, this is just my laziness that I put it into a single repo. Single repository. It can be totally different. All you need is a remote URL. As I explained in my demo, the app shell only gets the thing from the URL. There is no trace of code of remote in app shell. So it's totally independent. You can keep it in any other repo and build it there. All you need to make sure is it's available on the given URL. The remote entry file is the one which is looked for from HTTP address. And once you have the remote entry file, and it is sorted, then you don't need to have it parallel.
Maybe a small additional thing to clarify that even further. So like in your example, we've seen like in the Webpack configuration, there was like a hard-coded URL which points to localhost. How do you manage this in more real-life use case when, of course, you most likely have more than one environment? So you have the local dev, then you maybe have test or production. So how is this done then? Because the remote
I
can
mean,
live in different places, right?
yeah, we do that. I mean, we have staging URL, production URL, and testing URL, right? So, I mean, this is Webpack config. You can always use config variables here, like environment variable. So, at the build, this is build time process. Webpack config is the builder, right? So, at, for example, you are building, let's say, testing environment. So, you can pass your testing address of testing config. Let's say your URL is example.com/testing/remote entry.js. So you can manipulate this one, and for different environment, you can create different builds.
Makes sense. Thank you. Cool. Now we have a question from Marco. How do you manage repositories? Do you use Git submodules? It's a
No,
bit
we
under.
actually
Yeah,
use a we
please.
use actually templating engine. So instead of we find it a bit more realistic to make use of templating system. So we put all the stuff. The first repo we created, we put all the stuff which we need for the setup, as I explained, like it's maybe Docker setup, maybe a Kubernetes setup, whatever we need. We put it in this template, and then we spin new micro frontends with each micro frontend spin from this template. So it comes out of the box with all the goodies which we want for our micro frontends. And this tool also helps us to kind of update it time to time. Like, for example, we have a new requirement, like, okay, from Kubernetes, let's say we are moving to something else, or whatever architectural change we want to do. So instead of going into each micro frontends, we can just update the template, and just update the templates on the micro frontends too. So this gives us seamless kind of control over micro frontends and help them to keep in very similar structure.
But is this like, this is, if I understood correctly, like some kind of like custom tooling? This is not open source, right?
It is open source.
Oh, right.
It
Okay.
is
So
open
maybe we can
source.
also then share later, like or if you could share like the link in the chat so we can have all
I will do
look.
that. I will do
Perfect.
that. And that is
Perfect. So
very simple because this tool actually does nothing. It's literally maintains Git versions of the template. So when you update, so it's nothing more than just Git commit. It merges
right.
the previous commit to next commit, and if you have any conflicts, you will resolve as if it was any other Git conflict. So it's
Makes
pretty straightforward and in the same flow.
makes sense. Then we have another question from Nunzio. So, do you recommend creating a micro frontend for each component or for each piece of functionality? Can that various micro frontends be used standalone? And how do you manage the deployment of all the micro frontends? So we actually have three questions. So let's start with the first one. If you recommend to create like a very tiny micro frontends or more like something bigger for like a larger chunks of functionality.
I mean, I'm not in kind of in favor of creating very micro, literally mini or micro front ends, because it's really hard to handle. How I look at that is on a more broader way, like I want micro front ends per teams. Let's say a small team working, let's say up four people team is working on a small feature, that should be a micro front end, because it's just not about the structure of the code. It's more on the decision making of the team itself, like how the PMs want the priorities of the stuff. So I would connect it more towards the whole business process rather than just to the code, because that makes more sense to me, and it helps to see that whole team as a separate unit in terms of maintainability and the deployment and the velocity of the team. So it's pretty easy to kind of connect all these three things together.
Yeah, that makes perfect sense. Like it empowers that team. They don't have to like, they don't depend on the other teams. They can just push their code at their own speed and just like get stuff out. So that's pretty cool. Now then the other sub question there was like if those micro frontends, at least like in your organization, if they can be used also in like a standalone mode, or they only can exist inside of the shell?
I mean, for now we don't do that, but there's nothing stopping us to do so. Like the example I showed. So the micro frontend which I had has its individual entity. They were working on their own, and then when it was inserted into host, it was behaving as it was as if it was a part of the host. So it's totally on your architecture how you want it. Nothing
But
is
it's possible.
nothing on the architectural part. I mean, it's totally possible and it's totally doable.
Cool. And the last question was, yeah, how do you manage the deployment of all the micro frontends? But I think that's again ties to that thing about the templating, which you mentioned, that basically you generate those repos with all that configuration from the template, and this is why you don't have to like manage this manually on a case by case basis, but you have it handled centrally. Cool.
Correct.
Then we have another question from Radovan, which is uh, what if we use the same Angular library in multiple micro frontends? Will there be shared code loaded multiple times per each micro frontend? If yes, then the client loaded bundle would be huge, right? So this is, I think, more about the module federation. What is your experience with that?
Yeah, we stumbled on the same problem, but Module Federation actually is smart enough to handle this problem. So while defining Module Federation code in Webpack config, we can actually define some shared libraries. Like these are the code which we need only once in this whole app cycle. So, for example, Angular core or Angular routes, you do not need to load for every micro frontend, or even not for Appshell. So you load it once and mark it like, okay, this will be shared. So whosoever loads first, it will be there, and then furthermore, any micro frontend coming into that app session, they will be not loading the new version, a new instance of it, but using the existing instance.
Sounds good. Maybe one additional sub question to that. So now we have the situation when we are sharing like the versions, but we also have multiple repositories for various remotes and for the shell. So how do you manage like that the versions of all those consumed stuff like Angular router are still like managing in that range that they can actually be reused without any kind of like API conflicts or stuff like that?
So, I mean, to be honest, we don't have any kind of strict guidelines as of it now. It's more of a kind of we have a Confluence page where we keep the track of all the libraries used and whatever we are using. But having said that, like we have a very rigorous testing process. So, I mean, even though you are kind of deploying your or working on your different micro front ends, but at the end of the day, user sees a single website, right? It's a single piece of code for a user. Like any page
Yeah,
on the website is a single. So we test it in that way. We have end-to-end test which covers all the tests, right? So on every merge there is this test running. So if you have any issues, you will already know in the testing phase, like there's a conflict or something like that.
makes sense. So then there is another question from Ivo. Uh, uh, are micro frontends advisable when having the same tech stack, so Angular, or do you advise to use of modules in this case? Currently, we run modules with lazy loading, but dependency-wise. So I guess like it's more like in the direction that like would it still be advisable to use micro frontends if all of our code is, let's say, Angular, or all of our code is React, or is it better in that case just to go with standard libraries and standard dependencies?
I mean, I again, as I said before, I really do not tie this micro front end to the code. I tied it to the team, more of a team, because again, I want to achieve from this is individual deployments, like broken deployment. I don't want to deploy the whole thing together because that kind of decreases my velocity and this increases the chance of breaking things on live a bit more. Though, so granular, I can make more control of deployment I have. So same goes with this. Like even if we have the same tech stack, but if we have different kind of portfolios, for example, as I explained, we have a listing page and we have a detail page. These two teams are different, so they should handle different micro frontends, even if the same tech stack.
Makes perfect sense. Like this, when the organization grows and there are more teams and more people working on the same thing, then these kind of things becomes extremely valuable to have this option, like to not be blocked by everybody else. So it's not just the question of the technology used. Then we have another question from Ivo, context is from a single sorry, that was like additional, so that was like additional context to that question. From the point of view of the single team, now 3 teams are working on it on different features. Yeah, so exactly, that's what we discussed. It's more about the organization. So the more teams you have, the more benefit you can derive from this kind of architecture, because it empowers those teams to not be blocked by each other, which is always great. Then we have a question from Filippo. In terms of performance, is it better like the monolithic solution or the micro front-end solution? What is your experience?
I mean, I don't see any toll on my performance since we started micro front ends. I mean, I assumed like we will get, because when we were also exploring this option, we were thinking like, okay, can it be like we are facing some hit on the performance, but we had a POC and all. We really don't feel anything which is kind of delayed or adding latency to the stuff. The thing I believe why it is so, because it's literally coming out of the box from the module for Webpack itself. Like every magic is done right at the compile time. So that really kind of helps us to make sure that we are not losing on the performance front.
Yeah, I have to add to that. It really makes sense, because at the end of the day, if we have like a module federation, so like these core things like Angular core or Angular router, it's basically loaded just once, right? Because of the module federation, then there is actually not much difference in terms of like payload to load the micro frontend or to load the lazy route. But with the micro frontend, we have all these additional benefits of the independence. But like from the payload point of view, it should not really be that different. So this definitely make sense, and I hope that Filippo got his answer. The Denise,
I think
yeah,
adding one more thing onto that is like just consider that how we use lazy load components in any website, right? You don't pack everything together in one bundle. You chunk it up, right? So consider the same thing. Micro frontend is doing the same stuff. It's chunking out the stuff. So as if you are lazy loading the component in a monolithic app, you are doing the same with the micro frontend. So technically, it's the same stuff.
exactly. But there comes into play that it's really this module federation which enables that, because it removes like that duplication of all those core libraries, which would then of course have like a huge performance impact if you are bringing 5 copies of Angular and 10 copies of router and 7 copies of RxJS. But this is solved for
Correct.
us, right?
Correct.
So then the Denise is asking, do you always recommend the usage of micro frontends, or there are some? Okay, no, that we already had. Sorry. Then the next one is from Alice. In a Strangler fig pattern, does it make sense to wrap legacy features in a micro frontend? So sorry, my ignorance if I don't know this, but it says like Strangler fig pattern. Does it make sense to wrap legacy features in a micro frontend?
I'm not sure if I got that question. Sorry.
Yeah, so I'm not really sure about the initial part, but basically, most likely it's about like if we are trying to evolve like legacy code base to try to like wrap some of those legacy features in the micro frontends to bring them into this new world, if I understand correctly.
I mean, the thing is, like, micro frontend does not do anything to your code. Like, for example, you import stuff in modern JS, right? Like, before we require, now we import. It just makes sure that that part is changed. Like, the whole thing of micro frontend is it makes the thing available from remote to your local code base. That's the only thing micro frontend does. It can still do the same with the legacy one, or like, for example, consider like importing any node module. It's literally the same stuff. It's just that node module has to be on your file system. With micro frontend, it need not to be on your file system. It can be on remote. So you can literally do whatever you want.
So yeah, then Alice actually provided some clarification in the chat. So basically, she meant like migrate legacy features one piece at a time. But yeah, I think we already answered that. And then we have a question from Mattia, who is asking like, is the CEO affected in any way by micro frontends? Do we need to take care of something specific? So if we have like some customer facing things which should be like indexed and crawled, what are the implications of using this kind of architecture?
No, this has nothing to do with micro front end. I mean, if your app is server side rendered, I mean, it will already take care of SEO. So again, as I said, like this is nothing. This is not. This should not impact what the user sees. When I say user, the same for crawlers. It should get still the seamless experience. It is on your build time how you build the stuff.
So that means like even stuff like server-side rendering should be possible to implement in the context of the micro frontend, so that just
We
those
are doing
remotes
that.
will be loaded on the server during the request so that it can render the full template, right?
Yeah, micro frontend is supported on server side. I mean, we at Westwing we are a server side rendered React app, the whole our shop. So we use that. We cannot go without SEO. I mean, SEO is our main booster. So we have to make sure that everything works on the server side, and in micro frontends totally fit in this context.
Makes sense. We have one more question from Filippo. Can the host remotes array can the remotes array of the host be configured by the build configurations? So probably yes.
Yes. I mean,
So
that's what
that
I think you asked about the different environments, right? So it
exactly,
totally can be done. Yeah.
exactly. So this we already discussed, like it's a standard Webpack build, so it's possible to fully parameterize it per environment or from wherever you want. So it can be dynamic.
Correct.
Yeah.
Correct. But only at the build time. You have to be very sure only at the build time because Webpack config is used only at build time. So build time, you have to decide what is the URL of your remote entry and that can pick that up on runtime.
Yes. Cool. So looks like we have answered all the questions, but folks, please do not hesitate. It was like very cool that you had so many questions for our speaker. But yeah, if we don't have anything more, we are already a bit over time, which is definitely great because anyway, we are here for you. So if you have questions, we love to answer them. But one more. Let's go. So
I'll
Angelo,
be around anyway. I'll be around in
yeah.
case if you have more questions, you throw at me.
Well, the thing is, we will now have anyway like a coffee break, so it really doesn't matter that we are taking with much more time. So, and it's perfect that if people do have questions, that we can answer them. So, Angelo is actually asking if two micro frontends need to communicate with each other. Do they need to call the Appshell before, or do they communicate directly through these DOM events without the involvement of the Appshell?
Totally, it can be done via custom DOM even. So the thing is, that's why we use this native JavaScript. So if your micro frontend A, let's say, have the listener and micro frontend B emits the event, so it has nothing to do with Appshell or anything. There is a listener, there is a emitter. So as soon as the emitter emits the event, listener will react to it. So this is good. This goes beyond like a micro frontend or any other. This is basic JavaScript. So that's why we use this custom DOM events because it's super powerful and we really can kind of get the communication set without any problem.
Do you have some way to like make sense of what kind of communication is actually going on with everything in place? Is there like some way to map that?
Uh, not yet. But yeah, that's a very valid concern, I would say. But we are still working on it. I mean, as I said, it's a work in progress. But yeah, we need to kind of map that stuff. But we have some logs which we do ideally, but not all of them. But still, we have kind of cases where we know it can be a bit flaky or something. We do log that the message was received or not. I mean, that goes for every pub subsystem, right? This
Makes
part
sense.
for like any other pub subsystem, this behaves the same way.
All right. So I think we can wrap it up. There are not more questions. Oh, there is. The Julia is asking, where did you get the nice T-shirt you are wearing?
Okay, this T-shirt, I got it from 2019 when I spoke about PWAs in Verona at
Right.
JSD IT. So check that conference out. Maybe it's in soon in April, I guess. That's an amazing
Yeah.
conference. That's a super
Sounds
amazing
familiar.
conference.
Let's just say it sounds familiar, right? Yes, it's in
I guess
April.
so.
In
I
April
guess
in
so.
Corona, the conference is confirmed by the Julia herself. And we have still one more question. The Carlo is asking, what product do you use as a proxy for various micro frontends, containers / endpoints in production? How do you configure it?
I am not sure like why we. I'm not getting the question like why we would need proxy.
I guess it's more like in the direction that if we have like single URL which kind of hides the whole thing, so then maybe there are like maybe the paths are different, but it's sometimes there is this setup where you need to have a proxy to various those remotes, which it's kind of hidden that it's not like so many URLs. Depends. So instead of subdomains, it's all like on the same subdomain, and then it's like needs to be routed somehow behind the scenes. Probably this is the idea,
I
but
think
Carlo
that.
maybe can also clarify further.
Mhm. I mean, we generally have us we upload these micro frontend packages to S3 and serve it via CDN. So I mean, like any other asset we have on our website, this is served as an asset.
Right.
Does that make sense?
I hope Carlo clarified like he means reverse proxy, but for me, I still think like this was the answer, because in the end it's just a static piece of JavaScript. But anyway, it's time to wrap it up. We already are over time, but I think it was very cool. People had a lot of questions. We provided lots of answers. So Trishul, thank you very much for coming today, for sharing this very cool topic which has stirred so much interest, and I hope that we can see you at some future edition at the Angular Day or JS IT Day or whatever is the another conference they come up with, and see you soon. Ciao.
Ciao, ciao.